The General Theory of Relativity, Chapter 18, Special and General Principle of Relativity. The basal principle, which was the pivot of all our previous considerations, was the special principle of relativity, i.e., the principle of the physical relativity of all uniform motion. Let us once more analyze its meaning carefully. It was at all times clear that, from the point of view of the idea it conveys to us, every motion must only be considered as a relative motion. Returning to the illustration we have frequently used of the embankment and the railway carriage, we can express the fact of the motion here taking place in the following two forms, both of which are equally justifiable. A. The carriage is in motion relative to the embankment. B. The embankment is in motion relative to the carriage. In A, the embankment; in B, the carriage serves as the body of reference in our statement of the motion taking place. If it is simply a question of detecting or of describing the motion involved, it is in principle immaterial to what reference body we refer the motion. As already mentioned, this is self-evident, but it must not be confused with the much more comprehensive statement called the principle of relativity, which we have taken as the basis of our investigations. The principle we have made use of not only maintains that we may equally well choose the carriage or the embankment as our reference body for the description of any event, for this too is self-evident. Our principle rather asserts what follows. If we formulate the general laws of nature as they are obtained from experience by making use of A. the embankment as reference body, B. the railway carriage as reference body, then these general laws of nature, e.g. the laws of mechanics or the law of the propagation of light in vacuum, have exactly the same form in both cases. This can also be expressed as follows. For the physical description of natural processes, neither of the reference bodies, K prime, is unique or specially marked out as compared with the other. Unlike the first, this latter statement need not of necessity hold a priori. It is not contained in the conceptions of motion and reference body and derivable from them. Only experience can decide as to its correctness or incorrectness. Up to the present, however, we have by no means maintained the equivalence of all bodies of reference, K, in connection with the formulation of natural laws. Our course was more on the following lines. In the first place, we started out from the assumption that there exists a reference body, K, whose condition of motion is such that the Galilean law holds with respect to it. A particle left to itself and sufficiently far removed from all other particles moves uniformly in a straight line. With reference to K, Galilean reference body, the laws of nature were to be as simple as possible. But in addition to K, all bodies of reference K prime should be given preference in this sense, and they should be exactly equivalent to K for the formulation of natural laws, provided that they are in a state of uniform rectilinear and non-rotary motion with respect to K. All these bodies of reference are to be regarded as Galilean reference bodies. The validity of the principle of relativity was assumed only for these reference bodies, but not for others, e.g., those possessing motion of a different kind. In this sense, we speak of the special principle of relativity or special theory of relativity. In contrast to this, we wish to understand by the general principle of relativity the following statement. All bodies of reference, K, K prime, etc., are equivalent for the description of natural phenomena, formulation of the general laws of nature, whatever may be their state of motion. But before proceeding further, it ought to be pointed out that this formulation must be replaced later by a more abstract one, for a reason which will become evident at a later stage. Since the introduction of the special principle of relativity has been justified, every intellect which strives after generalization must feel the temptation to venture the step towards the general principle of relativity. But a simple and apparently quite reliable consideration seems to suggest that, for the present at any rate, there is little hope of success in such an attempt. Let us imagine ourselves transferred to our old friend the railway carriage, which is traveling at a uniform rate. As long as it is moving uniformly, the occupant of the carriage is not sensible of its motion, and it is for this reason that he can unreluctantly interpret the facts of the case as indicating that the carriage is at rest, but the embankment in motion. Moreover, according to the special principle of relativity, this interpretation is quite justified also from a physical point of view. If the motion of the carriage is now changed into a non-uniform motion, as for instance by a powerful application of the brakes, then the occupant of the carriage experiences a correspondingly powerful jerk forwards. The retarded motion is manifested in the mechanical behavior of bodies relative to the person in the railway carriage. The mechanical behavior is different from that of the case previously considered, and for this reason it would appear to be impossible that the same mechanical laws hold relatively to the non-uniformly moving carriage as hold with the reference to the carriage when at rest or in uniform motion. At all events, it is clear that the Galilean law does not hold with respect to the non-uniformly moving carriage. Because of this, we feel compelled at the present juncture to grant a kind of absolute physical reality to non-uniform motion in opposition to the general principle of relativity. But in what follows we shall soon see that this conclusion cannot be maintained.